with our Module 3 questions. Visual checks carried out on an installation switchboard. There's lots of them, okay? So you're going to have to look that up on 3000. And you'll be allowed 3000 on the exam. Grass test, purpose of proof test, the purpose of the proving the test instrument. So they want to know this one here, the prove and the prove. What's the purpose of that? That is to get a reading on your meter so you know your meter's working. And then at the end, when you do it again, is to get another reading on your meter so you know your meter's working again, so it hasn't broken between these 2 points here. You haven't knocked the lead out or anything. 4.3, use the diode to indicate where you connect your test probes to test the voltage of the supply. So what are you going to do? You've got to test the voltage of the supply, so you're going to get your test probes and you're going to put them there and there. That's going to be the supply. That's easy. List 2 faults that could occur with your meter and test leads that may cause the meter to give incorrect readings. Okay, you could maybe not have it plugged in properly. You could have broken leads. You could have your meter in the wrong setting. Lots of things could go wrong there. Motor, calculate the speed. We did that just up there. Remember, it's F times 60 divided by the number of poles. F 50 times 60, 3000 divided by the number of poles. Pairs of poles, sorry. So 4 poles be 2 pairs. So it's going to be 50 times 60 divided by 2. 50 times 60 is 3000 divided by 2, which will give you an answer of 1500. 1500. Alright, let's scroll down. What minimum should you have measuring voltages at a single phase at your switchboard? Cat 2, industrial switchboard. Cat 3, a higher voltage, a higher fault currents. Okay, so Cat 2, domestic. Cat 3 there. Use the diagram, but if you had a Cat 4 meter, you could use, or a Cat 3, you can use it anywhere, right? But that's minimum. Use to indicate where you connect your for incoming voltage. Incoming voltage is going to be 1 and 2. We just did that in the other question. What voltage is expected to measure between 1 and 3? Let's have a look. If I put a meter here and I put it there, the switch is open, the circuit breaker is open, so you're going to get no reading. You're going to get no reading, so I would put down none above. It's not going to be 0, it's not going to be 230, it's going to be D, numbers above. Select 2 faults from the list below that may cause your meter to give you no readings. What could give you no readings? That's weird. Flat battery will give you no reading. Broken leads will give you no reading. Not touching the contacts. That will give you a reading, but it'll be a wrong reading. Actually, they'll give you a reading, they'll be a wrong reading. Only one of them will give you no reading. Flat battery. Okay. No readings. So your meter's nothing on your meter at all. It'll be a flat battery. I can only think of one. I'm not sure about that question. 2 faults that may cause your meter to give no readings. Broken lead, you still have a reading on your meter. Okay. Not sure about that. I'd go that one for my second one. Not sure about that. Okay, select any 2 of the main parts of a DC generator from the list below. DC generator has 3 things. Has that, and field poles. So you could put down any of those 2 of those 3 there. They don't have slip rings. They have commutators, they have field coils and field poles. Here's our speed. What's this given? It's to give the synchronous speed. In the given format, NS is synchronous speed. So you can do that. 50 times 60 is 3000. 4 pole, so that's 2 pairs. 3000 divided by 2, 1500. Done heaps of those. visual checks carried on a switchboard. You're going to have to look that up. Regards to testing, describe the purpose of prove, test, prove. We just done that. Connect your, done that one, eh? 2 faults, lots of faults. Here's another one, 4 pole, 50 times 60, 3,000. 4 pole would be 2, so that'd be 1,500. Prove, test, prove, prove, test, prove. And install electric motor, and there's 2 factors selecting the correct cable for this. Okay, you're going to have to look at the size of the motor, you're going to have to look at the length of the cable, you're going to have to look at there'd be 2 things. Environment, so you want a pretty hard kind of insulation material, maybe a rubber plug top, lots of things you can put in there. They wanted you to focus on the cable though, okay? So the type of cable, the length, the motor, size of the motor, because they'll give you your current, they'll give you your volt drop. Motor be installed 4 pole, 4 times 50 times 60 is 3,000 divided by 4 pole, which is 2, which would be 1,500. Same question they keep asking. You have to look that up. Okay, what's this on a switchboard? Have a look at it. HM, hour, minute, day, clock. This is a time clock. Program it up, and this contact will come in and out. Time clock. What's this? It's a relay. It's got a coil there, and there's our contacts on the top there. So you've got a time clock and a relay. Prove, test, prove. Prove, test, prove. Done those questions. Done that one. Done that one. Done that one. Same question. Keep repeating. Done that. This is a thermal imaging camera, so they've put it on the switchboard. They've seen some hot spots here. Maybe 2 of these phases are hot. There might be loose connections or high resistance, or they're putting too much load. So what are you looking for there? You're looking for hot terminations, which indicate high current, which means overloaded cables maybe, or loose connections. Connect your test probe resistance to the lamp. You're going to go right from here. Where are you going to go? You're going to go from, and test the lamp. You're going to go there, and you're going to go there, and you're going to make sure you're on ohms. And should it be energized? No. Are you doing resistance? No. Find the missing words, you can do that. It's auto arranging, highest range, work to the lowest, 2 faults, done all that, done that, done that. We're there. Got to the end.